Welcome to lecture 28. Today we will learn about the RAID, another layer, RAID 5. In previous two lectures, lecture number 26, we have so far covered about the RAID, importance of RAID and RAID level 0 and 1. In lecture number 27, so far we have covered RAID level 2, 3 and 4. So today we will start from RAID level 5. So before starting the lecture, you have to know that the RAID level 5 is mostly and widely used version of RAID history. So basically it is used in geographically distribution of data, and it also having a very typical structure and algorithm to maintain the large data centers. So the main thing is its main target is to keeping the reading speed and the writing speed is higher, because the main technological problem was that in up to RAID level 4 was the writing speed is low, but in RAID level 5 it is overcome with some advantages, that is the write process is a bit more faster, and also it is improving the performance ratio also. So multiple writes is possible in the RAID level 5, so drastically it improved the performance. So the write operation is now doing the parallel. In RAID level 2 it requires the ECC disk, wherever the RAID level 3 it doesn't require the ECC code for error checking and correction, but it required the parity. In RAID level 4 it also required the parity, but it having some extra algorithm, because the hard drive and disk are going to be more smarter, as they are already able to check the errors from different disks. But in writing the blocks in different hard drive is not easy and not even the parallel in RAID level 4. So that's why the performance of writing is not as good as the RAID level 5. So the RAID level 5 is basically come out with some drastical and immersed performance in RAID history. So the RAID level 5 is mostly used all over the world in different organizations. So as I said, that RAID level 5 is basically used by the most of the corporate companies and who have the geographically distributed of data in different location server. Suppose like in RAID level 4, what is the thing is happening? In the RAID level 4, all the data are placed in a same strip of data, and the check disk is parity disk is in a single row. That as a S is, if a S is a data, S0 is a data. So in S0 data there are 4 parts. So S1, S2, S3 and S4, these are all S0 data. So these are come from different disks, but they are checking disk is in 5. So S0 will be converted, will be checked by the disk 5. But the problem is, if some disaster happen, if some problem happens, suppose like this, if we think that in a disaster this disk is going down, this disk is nowhere in the world, then what will happen? So basically all the data who have the parity in this disk all are going down, so no data will have any parity for check. So if that time a wrong data is transmitted, it will be shows right, because parity is going down, that all the disk, all the parities are going down. So that is a problem for the RAID level. So in the RAID level 5, what is basically happening here, there is no specifically disk is allocated for the parity. So parity is moreover distributed in different disks. Suppose like that a data, suppose like a data, a location, these are the 5 disks. These 5 disks are distributed in 5 geographical locations. Suppose disk 1 or this data is location in USA or America zone, it is in Europe zone, okay, so it is in Middle East, okay, so it is in Singapore or otherwhere, and it is in China. So these are 5 location, 5 data centers in different location. It is in USA, it is in Europe, it is in Middle East, and this is Singapore and this is China. So if suppose like a tsunami is happen and all the Singapore is going down under the sea, so what will happen? All these data are going down to the sea, so it cannot be recovered. It cannot be recovered. But how they can recover this data? If disk 1, disk 2 and disk 3 are parity, are make the XOR gate, XOR operation with its parity, which is still live in China, so they can retrieve the data of Singapore, right? Another thing is, if the parity is gone to under the sea, if he has the data of S1, S2, S3 and S5, S4 parity can be generated by XORing or maintaining the algorithm and regenerate this data, same like as S2, S3, S4 and S5. What is the problem of here? Suppose like the same example we can say here. So if this is America, if this is Europe, this is Europe and this is Middle East, and this is it is Middle East, this is Singapore and this is China. So if all the China server is going down, okay, so all the parities are going down in a single time. So all the parities are going down to the sea, no parity is happening here. So all over the data in 5 geographical location, America, Europe, Middle East and Singapore are live. These data are transmitted without any check-in disk and having any parity. So if some hacker or intruder is entering in the system, it can totally hack the whole system. But in here, what is happening here, that only single disk S1, its parity is gone, so might be this data is corrupted, but other datas are totally secured because their parity is still exist in different location, and by S0 data is somehow corrupted, but it also having the parity, it also knows the algorithm how to retrieve this data. So it is also retrieving this data from the different disk. So as RAID level 5 is basically working on the mirroring of the data, so these data always having some mirror in different location, so you can retrieve the data from other location. So this is how RAID level 5 is basically working. So as I said, best of all world, so read and write performance close to the RAID level 1. So RAID level 1, that is mean it having the geographical location redundancy, so it is mirroring the data in different location. So read level and write level is performance is going high. Basically we are focusing on the write level performance because read level performance is all over same. Require as much disk space as level 3 and 4, as level 3 and 4 having different algorithms to generate the parity, and basically these things are happening because of the technology advantage of the disk technology. In standard or advanced disk are having the technology built in of ECC, that is error checking and correction, so there is no need to generate the ECC code for other disk of data. So if we analyze the MTBF, mean time between the failure of the RAID level 0, then it is better than RAID level 0, we can say that. And performance, by this performance it is also good as RAID level 0. In RAID level 0 is just like stripping, so it is stripping in different geographical location and works is better. And one of the drawbacks is that the RAID involves heavily parity calculation, that I've already said, that different data having in different location. So if you want to generate the parity again, so it have to recalculate the parity algorithm and run for a long time, and also generating, so it might require some problem. But if you think that the all over the world the data centers are superly secured location and superly used in high technology buildings, so it is not all time happening. Might some problem happen about hard disk failure and these sort of things, but not the total server is going down. So that is why the operation may be somewhat slower if the total system is going down. So there is one single drawbacks here. So the another level is RAID 10. It is all over the world using this technology for the cloud and this sort of network. So in the cloud network, RAID level 10 is used, and these RAID level 10, it is not RAID level 10 exactly, it is said RAID level 10 because it is a combination of RAID level 1 and then 0. So in the RAID level 1, we are knowing that we know that RAID level 1 is a mirroring technology and RAID level 0 is a stripping technology. So it is merged up in a system that is called the RAID level 10. It is a high performance system and most expensive system because you are stripping the disk and you are mirroring the disk whole of the packed. Suppose like you want to buy some sweetmeat, so you are going to a sweet shop, you just like some sweet of different type and want to make a box. So you are choosing different sweets from different segments which price are not same. Some prices is lower and some prices is higher. So but you are combine some sweets of box in a same packet. Then you would like to make the mirror of this. So you want to make the exactly same packet for another box. So that is why whenever the some mixing of disk, whenever you are using some mixing of technology, it always may be high performance, because whenever you are testing different type of sweets, so all the sweets are not same. Some are very good quality and some are medium, some are lower, but you can test the highest quality of sweets. Accordingly, you have to pay more for the highest quality. So that is the thing happening in the RAID level 10. So how can you implement RAID level 10? But basically there are two things happening here. One is a software based RAID. So RAID, one is that is operating system having some influencing system that you can make the RAID system. So the RAID also can be made by some RAID software also. So that is happen basically RAID level and these sort of things are combination. Windows is not basically supported all the systems because it is developed for some for different types of command prompt. So if you use the Linux system for it or Solaris, Sun Solaris for the RAID, it works better in operating system if I consider. So you can also use the hardware in server level. That is not possible all time to make all the disk as a software RAID. So you have to make some hardware RAID. So there are some RAID controller. It is available in the market with the servers. So you can use the RAID level RAID hardware. So it is called the RAID processor. So it can separate and also modulate the hard drive data in a single disk, in a single controller level. It is something like looking like some graphics card and these sort of things. So it is just a controller and it controls more than 16 disks, as in the picture you have shown here. This disk can control 16 disks in a single server. So and now technologies are more advanced and these RAID controller is now supported up to 64 of disk by a controller. So these are huge. So that is the one thing. I have a review question for you, so I hope you will answer it you can answer it. Consider an array consisting of 4 750 GB disk. So what is the storage capacity of the array if we organize it? As RAID level 0, it's making the stripping. So how can you get the storage capacity? If it is RAID level 1, what will be the storage capacity? And if it is RAID level 5, what is the storage capacity? So that is the question. So a tricky question, so you have to answer it. Okay, so this is the last topic of this chapter is mean time between failure. It is an important thing. Server level, that is a thing that how many times a server can fail, a server can be failed, or these sort of things. So it is called the mean time between failures. So how can we calculate the mean time between failure? It's having some equation that is called the summation of downtime minus uptime and the number of the failures. So if it is a downtime and uptime, it is looking here. So it is the uptime arrows and it is a downtime arrows. So if suppose like the system is as the computer is start off in this firstly, and it is starting up at 11 AM in the morning, so it is running fine. So whenever the system is one failure happen at 11:10, so at 11:10 it having the one failure, and it is then again up the system by the engineer at 11:12. So that is a 2 minutes of system down. Then again the system is down in the evening time as 4 PM 4:11, and the system is up at 4:16. So 4 minute system down. So that is another failure happens. So we are considered up to this. So there is a 2 failure happen all over the day. So what is the equation is the downtime minus the uptime. So downtime in the, we are always calculating the downtime. So there is might be a value here that is 11:1. So, sorry, 11:11. So 11:11. That is mean the system is going to start to down at 11:10 and it is totally shut down at 11:11. But you have to calculate from the moment of it is going down, and you have to also calculate the moment when it is totally up, not from here. You are always calculating from these row. Okay, so you should not calculate. These data are for creating a vague statement or a confusion may create, but you have to always calculate from here. So the system is down here at 11:10 and also up here, so 11:12. So total 2 minutes down. So it is downtime minus uptime. So we will get 120 second. Another time it is 14:11. It is going to be down, and it is 14:16, 4:16. So it will up. So there are 5 minutes of lag downtime. So it is 300 seconds. So total 620 seconds is down. So 620 seconds is down total. Sorry, 420 seconds is down, and the number of failure happen in a day is 2 times. So these number will be divided by 2. So what is the mean time between failure? So this is the mean time between failure. Mean, that is mean the average. So average time to failure is it is 210. So 420 divided by 2, it is 210 second. So it is a simple math or simple query. So you have to analyze this, that how many times of failure. So the RAID levels failure and RAID level successful are defined, or these things are measured by the MTBF. So you have to know the calculation, how to calculate the MTBF. So that is the answer of your 3 questions we have analyzed in previous. So what is your result? Just check it with this slide. So thank you all of you.